Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So we need to first of all understand what a cube number is. So a cube number is the answer to when you get three integers or whole numbers and we multiply them by themselves three times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. Multiples are times tables, so the multiples of 2 are the times table of 2. So 2, 4, 6, 8, 10, 12, etc, etc. So the only number in this list that is in the 2 times table is the 6. So we can draw out our place value grid to help us out with this question. We've got thousands, hundreds, tens and units. So we'll need another one there. So thousands go here, hundreds here, tens here, and then units here. So this says 2000, so a 2 will go in the thousands column, 30, so that'll be a 3 there, and 2. So we need to fill in a 0 here to keep that 2 as 2000, otherwise that would collapse and it'd become 232. So the answer is 2032. If we write in how many sides each shape has, triangle has 3, quadrilateral 4, pentagon 5, hexagon 6, you'll notice the number of vertices is twice the amount of each of them. So if a shape has 15 sides, we just times that by 2 and it will have 30 vertices. So we're told the sequence starts at 20, so our first term will be 20, and we're told that the rule is add 5, so we're going to add 5 to that, and that'll be 25 for our second term, add 5 again, and that'll be 30 for our third term. Let's rewrite this expression but with a time sign in, so v times w squared. Now w squared just means times by itself, so we can rewrite that as v times w times w. Okay, so we know v is minus 10, so minus 10. And we know w is minus 4, so it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first. And I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. You will need to use a paper and pencil to do this physically. You can't really do this on the computer. And make sure you have a ruler and a compass. So the first thing we're going to do is draw our 10 centimeter line. And we're going to get our compass and we're going to measure the 6 centimeters for the left hand side. So we're going to measure 6 centimeters on our compass. And we're going to just put a little arc there. We can do the same on the other side for 8 centimeters. So we're going to do our 8 centimeter arc from the right hand side, and we're going to put the point of the compass here. it should be like that. And you can see where the two arcs overlap, which is here, and we can join these up with straight lines. And it says to measure the angle x, so we're going to need a protractor for this bit. I'm going to put our protractor here with the crosshairs matching here. So we're going to be looking at the inside, the outside one, and it comes up as 37 degrees. So our answer is 37 degrees. So we're going to start by doing a circle at -13 and a circle at -6. And x is between those values, so we're just going to join them up with a line. Probably move my circle down a little bit. Okay, next thing to do is figure out which of these dots are going to be filled in. So if it can equal that number, it gets filled in. So it can equal -13, so I'm going to fill that in. But for -6, it can't equal that, so it becomes a hollow dot. So to simplify 10 to 22 to 26, I'm going to have to find something that I can divide the 10, the 22 and the 26 by. The biggest number I can do that for is 2. So if you look, 10 can be divided by 5 but nothing else can, 22 can be divided by 11 but nothing else can, and 26 by 13 but nothing else can. The only thing we can divide all of them by is 2. So that would be 5 to 11 to 13. So the answer is 5 to 11 to 13. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit. And so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across. Let's try and get this just right. Line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s. And so this line here would be at 3. Okay, first of all we need to work out what the interior angles would add up to. So the sum of the interior angles is equal to n minus 2 times 180. Now n is the amount of sides, but it says it has 5 sides, so it would be 5 take away 2, which is 3, and then times 180, which would be 540. So we know it will add up to 540. So all we need to do is get that 540 and take away all the angles that we know. So the 118, the 84, the 108, and the 151. And when you do that, you get the answer of 79. The formula for the area of a trapezium is half a plus b times h. Now a and b are the lengths of the bases of the trapezium. Now it's easy to find the bases because they are the ones that are parallel. It doesn't actually matter which way round we label these, so I'm always going to put a on the left and b on the right, or I always put a on the top and b at the bottom, but it doesn't matter which way around you put them. The height, which is represented by h, always hits the bases, a and b, at 90 degrees. You can see that this length here does not hit the bases at 90 degrees. This is an acute angle, this is an obtuse angle. So that is not the height. The height is going to be this one here because it hits both of the bases, A and B, at 90 degrees. So let's put these values into our formula. So half times 5.4 plus 7.6 times 2.3. So that's going to be half of 13 times 2.3. And that's going to be 6.5 times 2.3. Then that will be 14.95. All the units are in centimetres, therefore the unit of the area will be in centimetres squared. First of all, we're going to work out what angle BCA is. And the way of working this out is it's going to be the same as what BAC is, because the angles in an isosceles, the bottom two angles in an isosceles, when it's pointed up, are equal. So this is also going to be 15x. Make sure you state the reason. So it's an isosceles triangle. Okay, so if this is also 15x, we know that angles BAC plus ACB plus ABC, so basically all three of the angles in the triangle, are going to add up to 180. So 15x plus 15x plus 30x is going to equal 180, because it's angles in a triangle. Get my lines in, my tram lines in. 15x plus 15x plus 30x, well 15 plus 15 is 30, 30 plus 30 is 60, so it's going to be 60x equals 180. Then we're going to divide both sides by 60, and we have x equals 3. So the answer will be 3. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So first thing to realise is that the formula for a volume of a cylinder is pi r squared h. So what we need to do first of all is work out the volume of the water butt that James currently has. So we're going to do the volume equals pi times the radius, which is 89 squared, times the height, which is 189. And when we do that, we get 1497,069 lots of pi. And I'll keep this in terms of pi just for simplicity. Now, what we want is we want the volume to stay the same. So we're going to keep that as the volume, 1497,069 pi. But we want the radius to change. So instead of the radius being 89, we want the radius to be 103. So times 103 squared. And we're trying to work out what the height is. Okay, so first thing we can do actually is just cross off the pi's from both sides. Actually, we don't really need them at all. And then we can get our solving things in, our solving lines, and we can divide both sides by the 103 squared. And on the left hand side we get 141.113 blah blah blah, and on the right hand side we get h. So the height will be 141.113. It says it wants it to 2 decimal places, so that will be 141.11. I'm going to start by expanding these brackets. You could have divided both sides by 2 and then expanded the brackets on the left, but I'm just going to expand them all because it might be maybe easier, I don't know. So we've got 2x minus 44. Get our lines in because we're solving. And the rule is that we get rid of the smaller amount of x. So we've got 2x here and 12x on the other side. So we're going to subtract the 2x from both sides. And so that'll give us 10x minus 84 is less than minus 44. So we've got minus 44 there, but that won't be a problem because we're going to add 84 to both sides. And so we've got 10x is less than 40. And then we're going to divide 10 both sides to get what x is, or what x is less than, and that would be 4. So our answer is x is less than 4. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19, and we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include A, S, V, and U? That's got a T in it, that's got a T in it, so it's going to be this one here. So let's write that out. V squared equals U squared plus 2AS. So that would be 34 squared equals U squared, because that's the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals U squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So to find the area of a rectangle, we just multiply the width and the length. So that's what we're going to do here. But whenever you have an expression representing a length or a width or anything really, you just put brackets around it. So we go u minus 2 times u plus 9. Okay, and the way we do this is with our grid. And I'm just going to draw out the grid. And so we've got u minus 2, and we're multiplying it by u plus 9. Don't want too many for some reason. And so we've got u times u, which is u squared, u times minus 2, which is minus 2u, 9 times u, which is 9u, and 9 times minus 2, which is minus 18. And what we're going to do is we're just normally going to be able to add these ones together. So our answer will be u squared, and then we're going to do 9u plus minus 2u. Well, that's just going to be 9u take away 2u, which is 7u. So plus 7u, and then minus 18 at the end. Whenever we solve, we've got to get rid of any fractions or brackets first. Now, looking at this, there's no fractions, but there are 2 sets of brackets. We've got the set of brackets here, and we've got the set of brackets here. So we're going to expand them to get rid of them. And you can use any method you want. I'm just going to use this kind of grid method. So we're doing 4 times, and inside the brackets we've got 3x plus 5. So I'm going to times those out. 4 times 3 is 12, so that'll be 12x. 4 times 5 is 20, so that's going to be positive 20. And I'm going to do the same for the other set of brackets. Now on the outside of the brackets we've got to be careful here. It's not a 5, it's a minus 5. And inside the brackets is an x and a 2. So minus 5 times x is minus 5x. Minus 5 times 2 is minus 10. So when we put it all together, we get 12x plus 20 minus 5x minus 10. And then the rest of it is just equals 52. So I'm going to start by putting my lines in because we're solving. And I'm actually just going to start by collecting the like terms on the left hand side. So 12x take away 5x is going to be 7x. And 20 take away 10 is going to be 10. Okay, now we need to get rid of the plus 10. So we're going to take away 10 both sides. So we've got 7x equals 42. And then we need to get rid of the times 7. So we're going to divide 7 both sides. So x equals 6. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. There's a lot going on with this question, so what I'm going to do is I'm going to put in all of the time signs that we don't normally show. So we've got 10 times 12x times y to the power 4 times 13 times x to the power 4 times y to the power 4. And I'm going to reorder these to put the numbers together, first of all. And with multiplying, it doesn't matter which way around you do it. So I'm not changing anything. I'm going to put the x's together. And I'm going to put the y's together. So, first thing to do is 9 times 13, which is just 117. Then we've got x to the power of 12 times x to the power of 4. Now we know when we multiply two powers of the same base, and the base is x on both of those, we just add the powers. So it's 12 plus 4, which is 16. It'll be x to the power of 16, and then y to the power of 4 times y to the power of 4, we just add them together, so it's y to the power of 8. So to find the probability of A and B, which is what that sign means, we're going to work out the amount of people, or the amount in A and B, and we're going to put that over the total amount. So A and B means it's the overlap, so that's going to be 7. And the total amount is all of the numbers added together, which will be 23. So our answer is that the probability of picking A and B is 7 over 23. So we've got a right angled triangle here, and we've got two lengths and an angle involved in the question. So we are going to be using trigonometry. And the first thing to do with trigonometry is label the sides. So the one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice that hypotenuse doesn't have a number or a letter next to it, so we're going to cross that out, we're not interested in that. And we're now going to just draw our triangles, our SOHCAHTOA triangles, so it would be SOHCAHTOA. And we've crossed out the H, so it's not going to be saw or cat, it's going to be toa, because toa is the only one without an H. So it's going to be tan the angle equals the opposite over adjacent. So the angle is 48, so tan 48 equals the opposite, which is x, over 2.3. And we're going to put our lines in. And notice here we just need to times by 2.3 both sides to get x on its own. Now be careful when you type in tan 48, most calculators will open a bracket after typing in the tan, so make sure you close it after the 48, then type in times 2.3, and we get 2.554 blah blah blah. And so when we round that to 2 decimal places, that would be 2.55. To work out the area of this sector, there is actually a nice little formula that we can use. And I'm just going to show you what the formula means. So the formula is going to be what fraction of the full circle do we have? Okay, so we're going to find out the fraction of the full circle we have. And then we're going to times that by the area of the circle. So to work out the fraction of the circle we have, we get the angle that we have in the sector, and we divide that by the total amount of angles in a circle, which is 360. Then we times that by the area of a circle, so pi r squared. Let's use that for our question. So the angle we have for this question is 57. Times pi r. Now, to work out what r is, we just imagine the circle is whole. I'll do a badly drawn circle. And you can see here that this length here, this 5 centimeters, is the distance between the center of the circle and the circumference. So that is a radius. So it's going to be times 5 squared. Put that into your calculator and you'll get 12.435 blah blah blah, and it says it wants its 2 decimal places, so we round that to 12.44 centimeters squared. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.